So in 8.6, we're going to continue to talk about angles, but specifically now pairs of angles. So let's take a look at the vocabulary word. We have 3 pairs of angles we're going to talk about before we get started. So we have complementary angles. Complementary angles are 2 positive angles whose measures have a sum of 90. So if the angle measures add up to 90, those 2 angles are complementary. So complementary angles are 2 angles whose measures have a sum of 90. So if 2 angles add up to 90, then they're complementary. Similarly, supplementary angles are 2 angles whose measures have a sum of 180. So if 2 measures have a sum of 180, then those are supplementary angles. So supplementary angles would be 2 angles whose measures have a sum of 180. So 90 is complementary, 180 is supplementary. That's what we have to remember. And then adjacent angles. Adjacent angles are basically 2 angles that are next to each other. Specifically, they share a common vertex and a side. So for example, if I draw an angle here and an angle here, although these 2 angles are next to each other, they're not adjacent because they don't share a side. They would have to look like this, here and here. These 2 angles are adjacent because they share a side and a vertex. So adjacent angles are 2 angles that share a common vertex and side. Let's write that definition for adjacent. 2 angles that share a common vertex and side. And they obviously can't have 2 sides in common, it would just be the same angle. So 1 side in common, in the example I drew, it's this side that I'm drawing in purple right there, and then obviously the vertex right there. So those are adjacent angles. So let's go ahead. In example 1, we're just going to identify what types of angles we have here. So you'll take a look in the figure. We've got several different angles. Now keep in mind, the angles I have here could be angle CAR. There's one angle. Could be angle CAD. Could also be angle RAD. So really in that one part, I have 3 angles. And then I obviously also have angle RST. So I've got really 4 different angles there. We're going to combine these in ways that we can get complementary angles, supplementary angles, and adjacent angles. So let's take a look at this. We have to name things, aside from maybe this angle over here, we could call that angle S. We can't call either of these angles A because A is the vertex to multiple different angles. So it says in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So let's start with complementary. If I'm going to name a pair of complementary angles, that means they're going to add up to 90. So my goal here is to find 2 things that add up to 90. Well, let's scan the measures that we have. 37, 127, and 53. If I were to add up this whole angle here, just kind of note that, what would we get? You should be getting 164, so maybe just worth noting we do have an angle that measures 164, which doesn't really help us right here because I'm trying to find measures that add up to 90. So it's not these 2 angles. It's not 37 plus 27. So let's try a few others. I know that 127 plus 53 is going to be way more than 90. What about 53 plus 37? What happens if I add 53 plus 37 degrees? Hey, I get 90 degrees, which means those 2 angles are complementary. So now I need to name the angles. I need to name this angle that's 37 degrees. I can either call it CAR or RAC. Doesn't really matter which one. So angle, I guess actually this should be a B. Sorry, I think it just got cut off. So let's change that to a B. So angle CAB. And my other angle on the other side, angle RST, are complementary. And that's how we would say it. 2 angles that add up to 90 are complementary. Let's move on to supplementary. Now I'm looking for two angles that add up to 180. Think 180, that's obviously a lot bigger than 90. Let's add 127 and 37, we know is 164. What about 127 plus 53? Hey, 127 degrees plus 53 degrees is 180, which means those two angles, angle CAD and angle RST, are supplementary. And then the last thing they want us to do is find a pair of adjacent angles. So adjacent angles would be two angles that share a common side and vertex. Well, take a look at our first picture here. CA, or ray AC, is a part of two angles. It's a part of angle CAB and angle CAD. Notice they share the same vertex. Vertex is always the middle letter, so A and A, so that's right. So those two are adjacent angles. Adjacent, supplementary, and complementary. Three different ways we can classify angles and pairs of angles. So let's go ahead and take a look at the next example. The next example now is going to give us some information and ask us to find missing angle measures. We're also going to have to use the angle addition postulate from back in, I think, 8.2. So I'll have to remember that as well. So part A says, part A is going to be this first picture, says angle 1 is a complement of angle 2, and the measure of angle 1 equals 62. Find the measure of angle 2. So what it means if they're complements, it means they add up to 90, and that's why we're able to put that little mark there that represents 90. So I know that these two angles add up to 90. The angle addition postulate says that if I add the measure of angle 1 plus the measure of angle 2, it should be the total, which they just told us would be 90 because of the word complement. Okay? Now, I know the measure of angle 1, it's 62, so let's fill that in, and then we have ourselves a little equation. 62 plus the measure of angle 2 equals 90. You can solve this by subtracting 62 on both sides, and we'll get that the measure of angle 2 is 28 degrees. You might even have been able to do that in your head or with like reasoning, because if we know these two are 90, we just have to basically subtract 62 from 90. Similarly, part B says angle 3 is a supplement of angle 4, so that means they're supplementary angles. They should add up to 180. We know that angle 4 is 47 degrees. If I want to find angle 3, kind of like what I just did, I'm going to subtract what I have, which is 47, from 180. So I'll go 180 minus 47 degrees, which means the missing angle measure, which in this case is the measure of angle 3, is 133 degrees. So again, we're using the angle addition postulate, which basically says we can add two parts of angles. We're also using our vocab words from this section: complementary, supplementary, and adjacent. Two more pairs of angles that we have. Let's take a look at our next two pairs of angles. We have linear pairs and vertical angles. So let's talk about what a linear pair is. Think about the word linear. We've learned about linear equations. The word linear means line. So a linear pair would be two adjacent angles that have a non-common side that are opposite rays. So it's basically, if I were to kind of give you the Reader's Digest version there, it's basically two angles that form a line. Two adjacent angles that form a line. Two adjacent angles that form a line would be a linear pair. Vertical angles, it says the two angles whose sides form two pairs of opposite rays. So I'm actually going to draw a picture. I think drawing a picture for vertical angles would be the easiest. So vertical angles have to be formed by two pairs of opposite rays. So let's say I want to draw a ray here. The opposite ray basically would go, that was bad. The opposite ray would basically go in the opposite direction. Remember, opposite rays form a line. So there's one pair of opposite rays. Remember, this is a line. So there's one pair of opposite rays forming a line. I need another pair of opposite rays. So I'll draw maybe a ray here and its opposite ray right there. So again, forming a line. What happens is those two opposite pairs form vertical angles. This angle and this angle would be vertical angles. So you can think about it as they're angles that are across from each other. They have to be formed by two pairs of opposite rays, so it has to be two lines crossing, okay? And they have to be across from each other. So those are our vertical angles. So now let's go ahead and identify some linear pairs and vertical angles. So it says identify all the linear pairs and all the vertical angles in the picture or in the figure. So let's start by creating our two categories here. We're going to identify all of our linear pairs and all of our vertical angles. So I'm just going to make two columns here, and under each column I'm going to write all of the pairs. So a linear pair would be two angles that form a line. Okay, let's take a look at the lines that we have here. That might help us. I have a line right here. I have a line right here, and that's it. Notice how this is not a line. Why is that not a line? Think about why that's not a line. It's not a line because it's a ray. So it can't form any linear pairs. So I'm not even going to worry about that. That means 2 and 3 are probably out because they can't form a linear pair. They're not on a line. They're on a ray. They have a ray. So what I do notice is that on this first line, 1 and 4 form that line. So my first pair would be angle 1 and angle 4. On my other line right here, on the top, I have 3, 2, and 1. So 3 angles would not be a pair, so that's not going to work. On the other side, I have 4 and 5. So angle 4 and angle 5 are a linear pair. So those are my two linear pairs. Let's take a look at vertical angles. Again, vertical angles have to be where two lines intersect. I have my two lines. The two lines intersect right here, which means I can look at this side or this side. Where's just two angles? Take a look. This is 2 and 3. If I would combine 2 and 3, then they would be a vertical pair with 4. But instead, I just have to look for an angle and an angle. That would be 1 and 5. So angle 1 and angle 5 are vertical angles. All right, let's take a look at the last problem here. The last problem says two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. So we've got a couple pieces of information. We know there's two angles. So I'm going to start by labeling our two angles. I'm just going to call it the measure of angle 1 because I know I'm going to find the measure, and the measure of angle 2. So not very creative. My two angles will be. So I know that those two angles form a linear pair. So I know that the measure of angle 1 plus the measure of angle 2 are going to equal 180. That's what it would mean if they form a linear pair because they're on a line is 180. Then it says the measure of one angle is 5 times the measure of the other angle. So let's write that as an equation. The measure of one angle, let's just say the measure of the first angle, is 5 times the measure of the second angle. So that this gets a little less confusing, I'm going to now replace the measure of angle 2 with x. Oops. So we're going to call the measure of angle 2 x, which means this would be 5x. So the measure of angle 1 is 5x, and the measure of angle 2 is x. So this is now 5x, this is now x, and it should equal 180. So now that I have my variables in there, I can actually solve this. 5x plus x is 6x equals 180, and I can solve that, which means x is 30. So the measure of the second angle is 30. We need to figure out what is the first angle. Well, the first angle is 5 times x. So the measure of angle 1 should be 5 times 30, which means the measure of angle 1 is 150. So my two angles are 150 and 30. Let's really quick make sure that those are a linear pair. 150 plus 30 is 180. They form a linear pair. One of them is 5 times the other one, so those are my two angle measures. So that's pairs of angles. We have supplementary, complementary, adjacent angles. We have linear pairs, and we have vertical angles. Make sure you know all of those vocab words are going to be really important, and go ahead and practice this then.